The very air crackles with anticipation as soldiers ready themselves for a new kind of warfare. A low hum resonates across the battlefield, signaling the activation of advanced laser systems. Then, a flash of light, instantaneous and absolute, as a laser beam cuts through the air with precision. Laser weapons, once the stuff of science fiction, are now a tangible reality, poised to redefine the very nature of warfare. This is a narrative woven into the fabric of human conflict, a testament to our relentless pursuit of new and more effective ways to wage war. What ethical boundaries must we establish in this new era of warfare, where the power of light itself becomes a weapon? It's about comprehending the future we are creating one laser pulse at a time and the profound implications it holds for humanity. The term laser hints at the mechanism behind these advanced weapons, which harness the power of light in a unique way. Laser stands for light amplification by stimulated emission of radiation, a process that involves amplifying light to create a powerful beam. A laser weapon amplifies light into a coherent beam, delivering immense energy over distances, making it a formidable tool in modern combat. Imagine the sun's rays concentrated to an unimaginable intensity, focused into a single point, creating a beam of extraordinary power. This process starts by stimulating atoms in a medium like gas or crystal, which is essential for generating the laser beam. Excited atoms release photons, tiny packets of light energy, which are the fundamental building blocks of the laser beam. Mirrors within the laser chamber reflect these photons, creating a cascade of light energy that amplifies the beam's power. This coherent light, where all the light waves are in unison, significantly amplifies their collective power, making the beam extremely potent. The result is a beam capable of traveling vast distances with pinpoint accuracy, capable of hitting targets with incredible precision. This precision and speed make laser weapons a game-changer in warfare, offering a new level of tactical advantage. Understanding the intricate science behind laser technology is crucial to grasping their full potential on the battlefield, where they can revolutionize combat strategies. The transition of laser weapons from science fiction to military reality is evident in the deployment of operational systems across the globe. These systems are now being integrated into various military platforms, showcasing their versatility and effectiveness in modern combat scenarios. No longer confined to research labs, laser weapons are finding their place in the arsenals of modern militaries, heralding a new era of directed energy warfare. These weapons offer precision targeting, reduced collateral damage, and the ability to engage multiple threats rapidly. The United States Navy, a pioneer in this field, has deployed the Laser Weapon System, LAW-DUS, aboard the USS Ponce, a testament to the growing maturity of this technology. The LAWS has been tested in various scenarios, proving its capability to disable small boats and aerial drones with pinpoint accuracy. This ship-mounted laser system has proven its effectiveness in neutralizing aerial drones and small boats, demonstrating the potential of lasers for defensive operations. The system's ability to engage and destroy targets at the speed of light offers a significant tactical advantage. Meanwhile, Israel has unveiled its own groundbreaking laser weapon system, the Iron Beam. This system is designed to complement existing missile defense systems, providing an additional layer of protection against a variety of aerial threats. Designed to intercept and destroy incoming rockets, artillery shells, and mortars, the Iron Beam showcases the versatility of laser technology in countering a range of threats. Its rapid response time and cost-effectiveness make it a valuable asset in Israel's defense strategy. These are but two examples of the burgeoning field of laser weapon development. Numerous other countries and defense contractors are actively working on their own laser systems, each aiming to enhance their military capabilities. From ground-based systems designed to protect military bases from drone swarms to airborne lasers mounted on aircraft for missile defense, the applications of this technology are rapidly expanding. These systems offer new possibilities for both offensive and defensive operations. As research and development continues apace, we can expect to see even more sophisticated and powerful laser weapons emerge in the coming years, fundamentally altering the dynamics of the battlefield. These advancements promise to enhance the precision, range, and lethality of future combat operations. Laser weapons, for all their futuristic allure, are not without their limitations. These advanced systems, while promising, face several technical and operational challenges that must be addressed before they can be fully integrated into modern military arsenals. One of the most significant drawbacks is their susceptibility to atmospheric conditions. Unlike traditional projectiles, laser beams can be easily disrupted by environmental factors, which can severely impact their performance in real-world scenarios. Rain, fog, smoke, and even dust can scatter and absorb laser beams, diminishing their effectiveness. This scattering effect can reduce the range and power of the laser, making it less reliable in diverse and unpredictable combat environments. This vulnerability to weather conditions poses a significant challenge for military strategists, potentially limiting the operational window for laser weapon systems in certain environments. Effective deployment requires careful planning and real-time weather monitoring to ensure optimal performance. Furthermore, current laser weapons are power-hungry systems, requiring substantial energy to generate and maintain a high-powered beam. This high energy demand necessitates robust power sources, which can be a logistical challenge in the field. This dependence on a robust power source can limit their deployment on smaller platforms or in remote locations. The need for large, stable power supplies means that laser weapons are often confined to larger vehicles or stationary installations, reducing their flexibility. Overcoming these limitations is crucial to unlocking the full potential of laser weapons and integrating them seamlessly into existing military doctrines. Ongoing research and development aim to create more efficient power systems and improve beam control to mitigate environmental effects. However, the advantages of laser weapons are equally compelling. Their precision targeting capabilities allow for highly accurate strikes, which can be critical in minimizing collateral damage and ensuring mission success. Their precision is unparalleled, capable of targeting and disabling enemy assets with surgical accuracy, minimizing collateral damage and civilian casualties. This precision is particularly valuable in urban combat scenarios where avoiding harm to non-combatants is paramount. This precision, coupled with the speed of light delivery of the laser beam, makes them ideal for countering fast-moving targets like missiles, rockets, and artillery shells. The instantaneous nature of laser strikes provides a significant advantage over traditional intercept methods. Moreover, the cost per shot of a laser weapon is significantly lower than traditional kinetic weapons, requiring only a readily available power source rather than expensive and complex munitions. This cost efficiency can lead to substantial savings over the course of prolonged engagements. This cost-effectiveness, combined with their speed and precision, makes laser weapons an attractive alternative to conventional weaponry, particularly in protracted conflicts. As technology advances, the role of laser weapons in future combat scenarios is likely to expand, offering new strategic possibilities for military forces worldwide. Section 5. The Global Laser Race: Leading Developers and Their Innovations. The pursuit of laser weapon technology has sparked a global race, with nations vying for dominance in this emerging field. Countries are investing heavily in research and development, aiming to gain a strategic edge in future conflicts. The United States, with its robust military-industrial complex and decades of research and development, remains at the forefront of laser weapon innovation. American defense contractors and military research institutions are continuously pushing the boundaries of what these systems can achieve. From the powerful LAWS system deployed by the Navy to the development of airborne laser systems for missile defense, the United States is heavily invested in fielding a new generation of directed energy weapons. These systems promise to revolutionize defense capabilities by providing precise, cost-effective, and scalable solutions. However, other nations are rapidly closing the gap. Countries like Israel, China, and Russia are making significant investments in laser technology, each bringing unique innovations to the table. Israel, with its iron beam system designed to intercept rockets and mortars, has emerged as a key player in laser weapon development. The iron beam system is part of Israel's multi-layered defense strategy, providing an additional layer of protection against aerial threats. China, known for its rapid technological advancement, is also making significant strides in this field, investing heavily in laser weapons research and testing. Chinese military researchers are exploring various applications, from anti-drone systems to space-based laser platforms. Russia, too, is actively pursuing laser weapon technology, showcasing systems designed to disable enemy satellites and drones. Russian advancements in this area are part of a broader strategy to enhance its asymmetric warfare capabilities. This global race for laser supremacy highlights the transformative potential of this technology and its perceived importance in shaping the future of warfare. Laser weapons offer the promise of precision, speed, and reduced collateral damage, making them highly attractive to modern militaries. Each nation brings its own unique strengths and strategic priorities to the table, fostering an environment of rapid innovation and fierce competition in this burgeoning field. The ongoing advancements in laser technology are set to redefine the landscape of military power in the coming decades. Section 6. Beyond the horizon, envisioning the future of laser weaponry. Gazing into the crystal ball of technological advancement, the future of laser weapons shimmers with both promise and uncertainty. These weapons, once the stuff of science fiction, are now on the brink of becoming a mainstay in modern arsenals. As research and development progresses at an electrifying pace, we can anticipate even more powerful and versatile laser systems emerging in the coming years. These advancements could lead to lasers with greater range, precision, and energy efficiency, making them indispensable on the battlefield. Imagine compact, high-energy lasers integrated into individual soldier gear, providing a defensive shield against incoming projectiles. This could drastically reduce casualties and enhance the survivability of troops in hostile environments. Picture swarms of autonomous drones armed with precision lasers, capable of neutralizing enemy threats with lightning-fast reflexes. These drones could operate independently or in coordination with human soldiers, offering a new layer of tactical flexibility. The possibilities seem limited only by our imaginations. From space-based laser platforms to underwater laser systems, the scope for innovation is vast and exciting. Advances in materials science could lead to the development of more efficient laser mediums, capable of generating higher-powered beams with reduced energy requirements. This would make laser weapons more practical and sustainable for long-term use. Artificial intelligence and machine learning algorithms could enhance target acquisition and tracking capabilities, enabling laser weapons to engage and neutralize multiple targets simultaneously with pinpoint accuracy. This would significantly increase the effectiveness of laser systems in complex combat scenarios. The integration of laser weapons into existing military platforms, such as fighter jets, warships, and armored vehicles, could revolutionize combat operations. These platforms would gain a significant edge in both offensive and defensive capabilities, altering the balance of power in military engagements. Imagine a future battlefield where laser weapons are not merely a niche capability, but a ubiquitous presence, fundamentally altering the tactics and strategies employed by military forces worldwide. This shift could lead to new doctrines and operational concepts, reshaping the very nature of warfare. Section 7. The Moral Dimension, Ethical Considerations in Laser Warfare. The emergence of laser weapons on the battlefield raises a host of ethical questions that demand careful consideration. These questions are not just about the immediate impact of the weapons, but also about the long-term implications for warfare and society. The precision of these weapons, while touted as a benefit in minimizing collateral damage, also presents a moral dilemma. The ability to strike with pinpoint accuracy could lead to a false sense of security, potentially making the decision to engage in conflict easier and more frequent. Does the ability to target and neutralize individuals with such surgical accuracy make warfare more palatable? Or does it simply lower the threshold for resorting to violence? This question is crucial as it touches on the fundamental nature of conflict and the value we place on human life. The potential for laser weapons to inflict severe burns and blindness adds another layer of complexity to this ethical debate. These injuries are not just physical, but can have profound psychological and social consequences for the victims and their communities. International conventions already prohibit the use of weapons specifically designed to cause blindness. But does the potential for laser weapons to inflict such injuries inadvertently violate the spirit, if not the letter, of these agreements? This raises questions about the adequacy of current international laws in addressing new technological advancements. Furthermore, the development and deployment of increasingly autonomous laser weapon systems raise concerns about the erosion of human control over lethal force. The delegation of life and death decisions to machines could lead to unforeseen and potentially catastrophic consequences. As artificial intelligence and machine learning algorithms play a larger role in target identification and engagement decisions, how can we ensure that these systems adhere to the principles of distinction, proportionality, and military necessity that govern the use of force. Ensuring these principles are upheld is critical to maintaining ethical standards in warfare and preventing unnecessary suffering. Section 8. A laser-focused future implications for global security. The proliferation of laser weapon technology has the potential to reshape the global security landscape in profound ways. These advanced systems offer unprecedented precision and speed, making them highly attractive to modern militaries. The accessibility of these weapons, particularly to non-state actors, could upset the balance of power, leading to greater instability and the potential for asymmetric warfare. Non-state actors such as insurgent groups and terrorist organizations could leverage these technologies to challenge established military forces. The relative affordability of laser weapons compared to traditional kinetic weapons could lower the barrier to entry for terrorist organizations or rogue states seeking to acquire these capabilities. This could result in a significant increase in the number of actors capable of conducting high-impact attacks. The potential for accidental escalation is another concern. In high-stress environments, the deployment of a laser weapon, even for defensive purposes, could be misinterpreted as an offensive action, leading to rapid and unintended escalation. In a tense standoff, the use of a laser weapon, even in a defensive capacity, could be misconstrued as a hostile act, potentially triggering a chain of events leading to unintended conflict. This risk is particularly high in regions with existing tensions and fragile peace agreements. Moreover, the deployment of laser weapons could spark a new arms race, with nations investing heavily in developing countermeasures and more powerful systems, further fueling tensions and diverting resources away from other pressing global challenges. This could lead to a cycle of continuous escalation, with each side striving to outdo the other in terms of technological advancements. Section 9. The Unwritten Chapter, a call for thoughtful development. As we stand at the precipice of this laser-focused future, it is imperative that we proceed with both caution and foresight. The rapid advancements in laser technology present both opportunities and challenges that must be carefully navigated. The development of laser weapons should be guided by understanding their potential consequences. This includes not only their immediate impact on the battlefield, but also their long-term effects on global security and stability. International dialogue is essential to establish norms and regulations for laser weapons. Collaborative efforts among nations can help prevent an arms race and ensure that these powerful tools are used responsibly. Investing in countermeasures like laser-resistant materials is crucial. These defensive measures can mitigate the risks associated with laser weapons and protect both military personnel and civilians. We must engage in a societal conversation about the ethical implications of laser weapons. This dialogue should encompass a wide range of perspectives to ensure that ethical considerations are at the forefront of technological development. This conversation demands the participation of ethicists, scientists, and citizens alike. By involving diverse voices, we can create a balanced approach to the integration of laser technology in military applications. The future of warfare is being written before our eyes, marked by restraint and responsibility. Policymakers and military leaders must work together to draft regulations that govern the use of laser weapons, ensuring they are deployed in a manner that upholds international law and ethical standards. The power of the laser is now in our hands. This technology, with its immense potential, must be handled with the utmost care to avoid unintended consequences and to maximize its benefits for humanity. The question remains, will we wield it wisely? The decisions we make today will shape the future of combat and the role of laser technology in our world.